boys and girls, it's Miss Bissell. We are working with a lesson 11.1. This is our first lesson in our new unit, which is volume and understanding volume concepts. So we have our introduction today. I do want to start it with a short video that I have embedded in my video so that you didn't have to flip-flop between two different videos today. And this is one of my favorite math videos people on YouTube. It's called Math Antics. So he's going to introduce volume and relate it to what you've done in fourth grade.
Hi, I'm Rob. Welcome to Math Antics. In this lesson, we're going to learn about another important geometry quantity called volume. Specifically, we're going to learn what volume is and what kind of units we use to measure volume, and how we can calculate the volumes of a few simple geometric shapes. The first thing you need to know is that volume is a quantity that all three-dimensional objects have. But to understand what it means, it will help if we back up just a little and start out with a one-dimensional object, like this line segment. To measure a one-dimensional object, we need a one-dimensional quantity, which we usually call length. The length of this line happens to be exactly 1 centimeter, which is a common unit for measuring length. And in the Math Antics video about area, we saw that if we move or extend this one-dimensional line in a direction perpendicular to it by a distance of 1 centimeter, it forms a two-dimensional object called a square. Two-dimensional objects are measured by the two-dimensional quantity that we call area. Because the original line was 1 centimeter long, and we extended it a distance of 1 centimeter, the amount of area that this square occupies is 1 square centimeter, which is a common unit for measuring area. Okay, now imagine that we take that two-dimensional square and move or extend it in a direction perpendicular to its surface by a distance of 1 centimeter. It forms a three-dimensional object that's called a cube. And to measure a three-dimensional object like this, we use a three-dimensional quantity called volume. Volume tells us how much three-dimensional space, or 3D space, an object occupies. All right, but how much volume does this cube have? Well, since it was made by extending 1 square centimeter, a distance of 1 centimeter in the third dimension, we say that its volume is exactly 1 cubic centimeter, which is a common unit for measuring volume. So square units are used to measure area, and cubic units are used to measure volume. Since square units are made by multiplying two one-dimensional units together, like centimeter times centimeter, we can abbreviate them using the exponent notation, centimeters to the second power, or centimeters squared. And since cubic units are made by multiplying three one-dimensional units together, like centimeter times centimeter times centimeter, we can abbreviate them using exponent notation, centimeters to the third power, or centimeters cubed. And just like there were different sizes of square units, like square inches, square meters, or square miles, there's also different sized cubic units, like cubic inches, cubic meters, or cubic miles. See how area and square units are related to volume and cubic units?
All right, we're going to stop right there, boys and girls. And now that he has given us a good introduction and related volume back to perimeter and area and linear units and two-dimensional units, let's just go back in our book to page 458. All right, our essential question that's going to guide us through this lesson and that we want to be able to answer when we finish with today's lesson is, how can you measure space inside a solid figure? So volume is the number of cubic units needed to pack a solid figure without gaps or overlays. A cubic unit is the volume of a cube that measures 1 unit on each edge. So here is our unit cube. It measures 1 unit on each of the edges, so this is a unit cube. Its volume would be 1 cubic unit. All right? Let's talk about a rectangular prism real quick. Rectangular prisms are three-dimensional solids. So we're looking at one right here where all of the faces, so we have 6 faces, each of the faces would be a rectangle. And we know from fourth grade that rectangles are parallelograms. They are actually a kind of quadrilateral, and they have 4 sides. Opposite sides are equal in length, and each of them have squared corners or 90-degree angles. Okay, so if you take a look, we've got each of these faces that we can see. 3 of them are rectangles. So that's a rectangular prism. Number 5 on the next page is a very special kind of rectangular prism that has a more specific name of a cube, and it's made of 6 square faces where every edge is the same length, because if you remember, a square is a rectangle. It's just a more specific rectangle where all of the sides are equal in length, just not the opposite sides, but all 4 sides. And then again, they have 4 right angles. All right, so we are going to look at what our little 5th grade helper's telling us. And she says each cube of a solid figure is 1 cubic unit. So in order to figure out the volume of this rectangular prism, our first step is if we had them, we could use unit cubes to make a model. So we would count the number of cubes that it took to make the bottoms. So what they're saying is that across the bottom, they had 1, 2, 3, 4, 5 unit cubes. So they'd fill in 5. Well, and then you could see that you have 1, 2, 3 wide. So you would put 3 rows of 5 to get 15 unit cubes on that bottom layer. All right, that bottom layer is 15 cubic units. Now what they would tell us is that there are 2 layers. So if the bottom layer has 15 unit cubes, the second layer is also going to have 15 unit cubes, and you would just multiply one of your layers times the number of layers. So 2 times 15 would give us those 30 cubic units. All right, let's take a look at the bottom convince me. In the picture below, how many unit cubes does it take to make the rectangular prism below without gaps or overlays? How many 2-cube towers does it take to make the rectangular prism? So we have a 2-part question. We want to know how many unit cubes does it take to make the rectangular prism? And then we want to know how many 2-cube towers does it take to make the rectangular prism? So let's start with the first part of the question. So what I notice is that I have 4 cubes on the top and the bottom layers. And this one I think is pretty easy to see. There are 1, 2, 3, 4 in length, and it's only 1 wide. So that right there, what we see on the top layer, we just see 4 cubes. Well, the same would be on the bottom. So 4 times 2, because we have 4 units on each of the layers, 4 times 2 gives me 8 cubic units. So 8 cubic units answers the first question. That is how many unit cubes it takes to make the rectangular prism. Now, the second part is how many 2-cube towers. So this is what they mean by a 2-cube tower. So I see 1 here, another here, and another there. So that is how many 2-cube towers. That would be 4, right? 2-cube towers. All right. If you need to pause the video at any time, think about something I've said and go back to it, then that's the beauty of using the video. All right. When you're ready, we're going to start with Do You Understand on page 459, and we're going to make a model of a rectangular prism with a bottom layer that is 3 cubes long by 3 cubes wide, and then we're going to make a top layer that is the same as the bottom layer. So what that tells me is I'm going to have 2 layers, right? A bottom and a top. And we're going to draw a picture of our model. Well, I don't have anything to make the model with because I'm like you, I'm at home, so I'm going to have to draw it. So I'm going to go back to what the question has embedded in it, and that is that it's going to be 3 cubes long by 3 cubes wide. So the first thing I'm going to do is draw my 3 cubes for my length. Here they are. And I'm going to draw 3 cubes for my width. And I'm not the best artist, but that works. All right. And then I'm thinking about this. You know what? If I have 3 cubes long and 3 cubes wide, I can use my multiplication and fill it in. I should have 9 cubes on this layer, right? And let's see what happens. I'm going to draw my second layer. So the front, here are my 3. And here are 3. And again, my top layer should have the same number. So 3 times 3 is 9. So I should have 9 cubic units on each layer. Now, we're going to close in. Oops, not the best artist. Ugh, not so great. But you can see I do have 1, 2, 3, 4, 5, 6, 7, 8, 9 on the top layer. I have 9 unit cubes. So 9 unit cubes on top layer. And we just said we have 2 layers. So 9 times 2, that gives us 18 unit cubes, right? So my volume would be 18 units cubed. It's made up of 18 unit cubes, but it's 18 cubic units, right? That would be the volume. All right, which takes us into our vocabulary. What is the difference between a unit cube and a cubic unit? So simply, a unit cube is a cube that measures 1 unit by 1 unit by 1 unit on each edge. All right, and a cubic unit is just a unit of measure. So here we go. A unit cube has a measure of 1 unit along each edge. So right here, we have a unit cube. 1 unit by 1 unit by 1 unit. Every edge is 1 unit, but if we want to talk about the length, the width, and the height, that's where we only are talking about 3 of them. All right, and then a cubic unit is how we name volume, because a cubic unit is a unit of measure. So when we just answered the question above with how many cubic, or what's the volume of our model, it's 18 cubic units. So that's how many unit cubes fit in our model without gaps or overlays. Pause the video if you need to get the rest of that. All right, number 3 and 4, we're going to use unit cubes to make a model of each rectangular prism. Well, I'm like you, I'm at home, we don't have that. So we're going to just analyze what we see in each of the models drawn. So I'm finding the volume. So this one right here, I see is 2 units long and 2 units wide. So there are 4 units on each layer. And you can see it if you look down over this volume and see the light color. That is actually the top of the 4 unit cubes that are on the top layer. So I have 4 cubic units on each layer. So I have 2 layers. So I have 8 cubic units in all. All right. The second model, number 4, I look at this one. This is only 1 layer. And this one's easy to see. I have 1, 2, 3, 4, 5, 6 units long and 1, 2 units wide. Well, 6 times 2 is 12. So the volume of number 4 is 12 cubic units. Now, don't forget, we could write this with using the abbreviated, we could abbreviate it using the exponent notation. So we could say that we have 8 units cubed, or we could write this one as 12 units cubed. Okay, there's 2 different ways you could write your volume as an answer. All right, why don't you try some with me? We're going to do number 5 together, and then you're going to pause your video and you're going to work on 6 through 12. So number 5, I'm going to look at my length and width. And I can look at any one of the layers. I know there's 3 layers, but I see 1, 2, 3 units long and 1, 2, 3 units wide. So 3 times 3 tells me that each layer has 9 cubes on it, right? That would basically be the area of each layer. So 9 unit cubes on each of the layers, and there are 3 layers. So we just use our quick little multiplication facts, and we know that we have 27 cubic units. All right, so your work should look like mine, and you are welcome to quickly pause the video, work out 6 through 12, and see how you do with this. And I'm going to put up my answers that I have already worked out for these. All right, so I've already worked these out. I'll be glad to talk about these quickly. So number 6, you should have 24 cubic units. There are 8 cubes on each layer, and I know that because we have the dimensions for length to width. So that gives us 8 units on each layer, and there are 3 layers, 24. Number 7 should be 40 cubic units, and I know that I have 20 units on each layer. Each layer is 5 units long and 4 units wide. 5 times 4 gives me the 20 units on each layer, and there's 2 layers. Number 8, you should have 16 cubic units. All right, you have 4 units long, 2 units wide. That's where I get 8 units for either the top or the bottom layer, and you've got 2 layers. 8 times 2 is 16. This one right here, number 9, is 10 cubic units. You actually have 2 units on each layer, and you have 5 layers. 2 times 5 is 10. Number 10 should be 18 cubic units. I have 2 units long, 3 units wide. So what I have, 2 times 3 is 6. I have 6 units on each layer, and I have 3 layers. So 6 times 3 is 18. 18 cubic units. Next, I have number 11, 36 cubic units. And there are 12 cubes on each layer. 1, 2, 3, 4, 5, 6 units long, 2 units wide. So that's where I got the 12. 6 times 2 is 12. 3 layers. 12 times 3 is 36. Number 12, I have 2 layers, and I have 3 units long, 4 units wide. So 12 units on each layer. All right, and then let's talk about number 13. Number 13 is cool. All right, if you can look at number 13 and imagine this as 2 rectangular prisms that have been put together to make one solid, this is going to make this problem super easy for you. So I noticed that this tower part is one rectangular prism, and I noticed this little area out to the side is a second. So let's talk about the tower first. So the tower part, if I want to figure out how many cubic units are in it, I notice they're 2 wide, 2 long, 2 wide. So that is 4 units on each layer, and there are 4 layers. So it is 16 cubic units, right? Now, the left part is only 1 layer. And I see that there are 1, 2, 3, 4, 5, and there is a whole cube behind this. We just don't see it at the angle. That gives me 6. So this left part is made up of 6 unit cubes. So if I add it together, the 16 unit cubes on the tower plus the 6 unit cubes on the left part, I get that there are 22 unit cubes, or 22 cubic units for the volume of this composed solid figure. All right. So boys and girls, let's go back to our essential question for today. How can you measure space inside a solid figure? And I hope that what you're seeing is that we can measure space when we can see the unit cubes, and we can count the length and the width and the number of layers, okay? So we basically looked at the length and width of each of our layers, and they're all the same, so we just picked one layer. We multiplied the length times the width to get how many unit cubes were in that layer, and then we multiplied the number of layers times the number of cubes in each layer. So you're going to do the practice buddy. I highly suggest, because I really want to see the math on paper, that you had a sheet of paper, practice buddy lesson 11-1, and you can even put that, the work is coming from page 458 to 459. That's where the concept was covered in the book. And you need to work your problems out on paper before you start clicking answers on the computer. All right. Don't forget, you have a get help button. So if you need any help while you're working on the practice buddy, I think most of the options are you can watch a short little video clip. You can have a similar problem worked out for you where the computer teacher explains it to you, or you can get help working yourself through this problem. But I don't think it gives you full credit if you get the help button where it works you through the problem. All right. Practice buddies, if you don't like your score and you aren't happy with it, you can rework the practice buddy for a higher score. All right. So I'm going to let you work on that. Keep in mind, you guys, that you are always trying to do your personal best on every assignment, and that we are working for understanding, not working just to finish our assignments and check them off. Okay. All right. Well, I hope you have a wonderful day, and I will see you tomorrow.